Hi, you are now looking at the teaching video of application of differentiation, especially in kinematics. Firstly, we are going to look at the symbols used in kinematics. For S, it represents displacement. For V, it represents velocity. And A, which represents acceleration. All these quantities are called vector quantity. What does that mean by that? It refers to all these quantities are having its magnitude and direction. So when we talk about magnitude, especially in this case, displacement, we are referring to distance. And direction, when we are talking about displacement, it refers to how far it is from the fixed point O. So you would expect that since we are talking about directions, so negative values are possible for displacement, velocity and the acceleration, depending on the directions of the particle moving. Contrast the term velocity with speed, where speed is a scalar quantity, which means that speed will never be a negative values. But for velocity, if my travel along this direction is positive, which means that if I travel in reverse, it will give me a negative values. So in short, for displacement, velocity and acceleration, since they are vector quantity, so there will be two portions of them which covers magnitude and also direction. Now we will focus on displacement. So displacement of a particle is measured from its origin to where it is. So the origin here refers to the fixed point O. Well, there are two cases here. First, we will talk about the first case where there is no turning. So we will start from the first point where t is equivalent to 0 second from the origin. And then it is moving to the right, okay? And at the instance, it will be equivalent to t equals to 2 seconds. So as you can see here, from t equals to 0 seconds to t equals to 2 seconds, there is no turning. So if s with respect to t is the displacement function which describes the displacement of the particle from the origin, the distance traveled will be equals to, simply substitute the value of t, which is equivalent to 2, in the function of s. So we can say that, okay, substitution of 2 in the function of s. Or we can even say that this is the distance traveled is also the displacement, whereas with the substitution of 2 refers to the displacement of the particle at t equals to 2 seconds. We move on to the next part where the particle is moving with turning. So for instance, if I have a particle starts its journey when t is equivalent to 0 seconds, okay? So when it comes to this point, it decided to make a turn at t equals to 2 seconds, and then it go reverse in this direction, reaching this point at t equals to 3 seconds. If s of t is the displacement function describing the displacement of the particle from the origin, then the distance travels, we have to consider the part where it is traveling from this point to this point. Okay, this can be done where we are actually substituting s equals to t equals to 2 in the function of s. The next part is we have to look for the distance traveled from this point to this point. Okay, so to do this, I can say that I need to find out, okay, what is the value from this part to this part, which we can find this value as s equals to s with t equals to 3, because that is the displacement of the particle travel at t equals to 3 seconds. Hence, to find the total distance traveled by the particles, firstly, we take the distance traveled by the object forward as substitution of 2, okay, multiply by 2, considering the whole distance from this part to this part. Okay, so it's two-way, one way forward, another way in reverse, minus out the displacement at t equals to 3. So in this case, as you can see, if the object is moving with turning, we have to mark the pathway of its travel. Okay, as you can see, first it travels from this point to this point, okay, and then making a U-turn, okay, which travels from this point to this point. So there are two pathways. So we are taking the total distance traveled by the first pathway here plus with the second pathway here. Alright, so hence we can say that the distance traveled by the particle cannot be written as displacement of the particle. Why? Because if you have a particle travel, and then if you are looking for s3, okay, that means displacement of the object at t equals to 3, okay, you are only getting the distance from here to here. Okay, you are only getting the distance traveled from the origin, okay, when t equals to 3. Okay, only this particular part. So the distance traveled is not equivalent to displacement of the particle. So for you to solve the kinematics question effectively, okay, so there are some common phrases which you need to know so that it triggers the idea of what you need to actually put in for the problem solving. For example, the first one, if question mentioned t second after passing through O, what does that mean? It means that when t is equivalent to 0 seconds, s will be equals to 0 meter. That is the first. Okay, so when question referring to returning to its origin at t equals to a second, okay, it tells you about when the displacement, when t is equivalent to a, it is coming back to the origin, which is 0. Okay, when the object is at its origin, okay, s is always equals to 0. Next, we proceed to maximum displacement. So when we are talking about maximum displacement, you have to trigger an idea whereby ds over dt, which is equivalent to v, has to give you 0. Okay, it's because maximum point or minimum point always having 0 gradient. That is the reason why velocity equals to 0. Okay, and then it also correlates to another information where you have the second derivative of displacement over time, okay, will be equivalent to acceleration. So when we are talking about maximum displacement, the acceleration must always be lesser than 0. Continue with the next part, which is the minimum displacement. Okay, same thing. When we are talking about turning point, minimum here, okay, ds over dt, which is equivalent to the velocity, will always be 0. The gradient to be 0. And then it correlates to acceleration, where acceleration will always be more than 0. Now we are looking at velocity. Okay, velocity is actually differentiate the equation of displacement with respect to time. We will look at some common phrases in velocity. Firstly, initial velocity. Initial velocity refers to when t is equivalent to 0 seconds. When we say that a particle is instantaneously at rest, it refers to velocity will be equivalent to 0 meter per second. Next, we will move on to maximum velocity. When we are talking about maximum velocity, it refers to the derivative of v over time. Okay, so when it is maximum, okay, we let the derivative equivalent to 0, and we know that differentiate equation of velocity over time also gives us acceleration, which means that acceleration must also be equivalent to 0. Now, if we want to determine whether the velocity is maximum or not, then we have to look at the second derivative of the velocity. When you calculate, okay, the second derivative of the velocity, which is, you found that it is lesser than 0, okay, it means that the velocity is maximum. Okay, continue with minimum velocity, same concept. Okay, differentiate equation of the velocity, which is giving us the acceleration, and when it mentioned minimum, it means that the derivative of velocity will be equivalent to 0, because the gradient of the velocity time graph is equivalent to 0. And for us to determine whether the velocity is minimum or not, we have to perform the second derivative for velocity. We found that acceleration is more than 0. It shows that the velocity value is minimum. Now we will look into more details when the particle is in its travel. So when a particle turns when it is traveling, we say that the velocity will be 0 meter per second. And the sign of the velocity, the sign here refers to either it is positive or a negative. So the sign of a velocity will change. So it is changes after the particle's turn. For instance, if I have a particle, okay, we start off with the point of origin at t is equivalent to 0 second and move to this direction, say reaches t equals to 2, and then later it makes a turn here and reaches this point at t equals to 3 seconds. Okay, so the velocity of the particles, if it is moving this way, velocity is equivalent to a positive value. It tells us that a different direction, okay, when it turns, the velocity will become negative. Hence, this shows that the sign of the velocity changes after the particle turns. Another case is when the velocity, okay, it must be equivalent to 0. It must be equivalent to 0 when it turns. Okay, so the displacement of the particle, what will happen to the displacement of the particle. If we are looking at the same diagram, if you notice, right, so from here, okay, this is the origin. When it is moving towards the other side, the displacement of the particle is actually getting bigger and bigger. So when it turns, okay, the displacement of the object is going smaller because it is approaching the origin. Hence, we can say that the displacement of the particle, when it turns, it will decrease. Okay, it decreases because it is moving nearer to the origin. Lastly, we will look at acceleration. So there are two ways to explain acceleration. First is, you just put it as the second derivative of the displacement with respect to t. The second is, okay, acceleration is equivalent to the derivative of velocity with respect to t. We have come to an end of this video, so this is just the brief overview of the topic on application of differentiation in kinematics. Thank you for watching.